Hello, today I'll be talking about my research titled The Intelligent System to Estimate Food Calories to Aid in Balanced Diet Using Computer Vision. Let's first take a look at the problem statement. The problem statement is that the steady increase in obesity rates globally raises major concerns and will present a great health risk in the future. This is due to two identified issues, which is the lack of caloric values for food items and also the difficulty in keeping track of calorie intake for the average user. Moving on, the potential benefits of having an application to track eating habits based on computer vision is that it allows users to know the correct value of their meals and helps users in planning out their diet for weight loss. The intangible benefits include the application will help to combat the rising obesity rates globally. So moving on is the technical research. So these are the various programming languages and libraries used to complete the application. And this is the system architecture for the application itself. So you can see that the application is split into two parts, which is the web application and the food detection model, which is hosted using the Fast API library, which is powered by Firebase using the Firebase authentication and Firebase Firestore services. So this is the architecture diagram for the model. So it uses a base model of a mobile net v2 and uses a custom added layers to increase the overall performance of the model. So currently this is the result of the model. So it is trained to identify 10 classes of food items, mostly Malaysian food items, and it achieved an overall accuracy rate of 89%. So there are certain improvements that can be made for this application, such as a better UI, manage food intake, recommend diet, provide caloric breakdown, and larger dataset on food items. Moving on, we will be having a demonstration of how the application works. Welcome to my demonstration of my project called the Food Calorie Tracker. So as you can see here, this is the login page or the sign up page. So the user has an option whether to sign in using their email and password combination, or they can sign in using their Google account, which is what we're going to do here. So press this button, sign in with Google account. It will redirect you to the Google authentication. So select which account you want. Alright, then the rest of the functionality of the application is made available to you. So the next part is this image box here. You can see drag and drop image files here. So I'm just gonna use a pre-selected image here. So you select an image here, and once you can see, you have the option to crop the image. Because this image has a lot of background that we don't really want. The image is only the food is only one small part of the image, so you want to focus on that. So you can use the mouse wheel on your mouse or the slider over here to adjust the image accordingly. So once you're happy with that, press Save Changes, and it will display the crop image here. Then you press Check Caloric Values, and the small pop-up will say data source 3. When you scroll down, you will see which particular food that the model actually detects. The model has been sent using it's also using API, so that's how we're able to get this running. So you can see additional food information such as the name of the food, the burger, the description, the ingredients, which is useful for certain dietary restrictions, and the most important one is the calories, 50 calories in this case, as well as the other information such as number of carbohydrates per serving. So let's say, for example, if the prediction makes a mistake, we also have the option to change the food. So for example, change the food to our national dish, nasi lemak. Just check caloric values, change to nasi lemak. So once you're happy, you press submit and refresh. If you refresh, the latest one will be updated over here. Yes. So over here we can also set the daily limit. So let's say you're on a weight loss plan, you want to limit yourself to only 1000 calories a day. So you can do that. You can change this to whatever value you want. You can see when I change the value, it will change depending on limit. So red indicates that days where you're going over limit, and green indicates days where you are under the limit. So using this, we hope that the user can track their weight loss journey and make meaningful decisions in planning their next meal. That's all from me. Thank you.